Hello students, welcome to the course Numerical and Statistical Method. Today we will study about Newton-Raphson method. Newton-Raphson method gives result more faster than bisection method, iteration method and regular fallacy method. Therefore, rate of convergence of Newton-Raphson method is faster as comparison to other methods. Sometimes this question also came in MCQ that which method gives quicker result or which method has fastest rate of convergence. Then in that case you have to put Newton-Raphson method as your answer. So first we will study about Newton-Raphson method, that what is the formula of Newton-Raphson method. Then we will take some examples in which we will take some algebraic equation and transcendental equation to solve that equation with the help of Newton-Raphson method. So first what we have to do, first let x naught be an approximate root of the equation fx equal to 0. If x1 is equal to x naught plus h, means first we will consider that x1 equal to x naught plus h be the exact root, then fx1 is equal to 0. Means you know that whenever we will put the root in any equation, then our equation turns to 0. So this I have written. Expanding fx naught plus h by Taylor series. Taylor series is new for you all because you have not studied earlier about Taylor series. So Taylor series is just with the help of Taylor series we can expand this equation as in this form. Fx naught means fx naught plus h is there, so we can write it as fx naught plus h f dash x naught. This dash means single differentiation, means one time you have to differentiate. H square by 2 factorial f double dash x naught means 2 times you have to differentiate, and so on, and afterwards you have to write equal to 0. Since h is very small here h is very small, so we will neglect the higher values. Like suppose 0.02, if you will do square of this number, then you will get 0.0004, which is more smaller than 0.02. So whenever you are doing squares of some smaller number, then after squaring it will become more smaller, so we can neglect that all values. So after neglecting h square and higher powers of h, we will come up with fx naught plus f dash x naught, and these all will be deleted, so this whole become this equal to 0. So from this equation we can find out the value of h equal to h f dash x naught equal to, this is in plus, so it will go on that side, then it will become minus of fx naught, and h will become minus of fx naught by f dash x naught. So this only I have written here. So this is the value of h. A closer approximation to the root is given by, so what we have considered earlier, we have considered x1 is equal to x naught plus h. So we can now substitute in place of x naught only, and in place of h we will substitute minus of fx naught by f dash x naught. This I have substituted in place of h. So this is our approximation. So if we will, this is the first approximation. So if we have to write the second approximation, we can write x2 equal to x1 minus of fx1 by f dash x1. This we can write as here 1 is there, then here 0 0 0. So if we will write 2, then it will become 1 1 and 1. If suppose I have to write n plus 1, then it will become fn minus fxn divided by f dash xn. So these are like this way we can proceed here in Newton's-Raphson method. Okay students, here I have taken one question in which you have to find the positive root of x to the power 4 minus x equal to 10. Correct to 3 decimal places, that your root must have 3 decimal places. And here first we will consider x to the power 4 minus x equal to 10 as my fx. This is the equation. If this 10 is in positive sign here, it will come before equal to sign, then it will become minus. So fx is x to the power 4 minus x minus 10. So again we will substitute some values and we will check that at what value it is giving positive and negative roots, as we are doing in earlier method, like in bisection and iteration method we are doing same. So we will first check in 1. If we will check in 1, then it will become 1 to the power 4 minus 1 minus 10. It is all about 1 minus, it will become minus 10, which is negative. If we will check at 2, then my value is 2 to the power 4, it is 4. 16 minus 2 minus 10, so this value will become 4, which is positive. So this shows that a root of fx lies between 1 and 2. So this is, so now we can take any of the value, because in earlier method also we are choosing anything, like in iteration method we are doing that x naught we have to choose one value. Similarly here also we will choose one value between 1 and 2. So I am taking as x naught equal to 2, because my root is so much near between x2. Because see, at 1 it is giving minus 10 and at 2 it is giving 4. So if suppose I am drawing a number line here, and number line here it is 0, then minus 10 is very far and 4 is little bit closer to 0. So at 2 it is giving 4 and at 1 it is giving minus 10. So my answer is, my root is so much near to 2. That's why I am taking x naught as 2. Okay. Now after taking x naught as 2, we have to also find f dash x naught. F dash x, we have to also find f dash x. How we will find? We have to differentiate x to the power 4 minus x minus 10. So if you will differentiate x to the power 4, it will become 4x cube. Why it has came? Because we know that x to the power n differentiation is equal to n x to the power n minus 1. So this 4 comes here, and here it will become 4 minus 1, that is 3 minus 1. This is f dash x. Now this is f dash x, and we have got all values. So with the help of this, now earlier only I have explained the formula of Newton-Raphson method, that the formula is for x2 it is x1 minus fx1 f dash x1. And if suppose you have to find the value of x1, then you can find it as x1 equal to x naught minus fx naught divided by f dash x naught. So this is the formula of Newton-Raphson method. So similarly we will do the same here. We will write it here x2, because we have to first find the first approximate with the help of Newton's-Raphson method. Newton's-Raphson method, or you can write here formula, tells us that x to the power xn plus 1 equal to xn minus fxn by f dash xn. This is the formula of general formula. This is the general formula of Newton's method. This is known as the general method. So I'm just highlighting this. Now first we have to find the first approximation. So let us consider, we will first put n equal to 0. If we will put n equal to 0, then it will become n1 equal to n0 minus of f x naught divided by f dash x naught. Okay, so how we will find the value of this? We can find the value of this by using x1 equal to x naught. X naught is already 2, so we can put here 2 minus fx naught means f2, and then f dash 2. So how we will find this? F2 we will find with the help of f. This is the fx, so we can put here f2 as 2 to the power 4 minus 2 minus 10. So it will become f2 is 4. And if suppose we have to find f dash 2, then f dash 2 is 4x cube. Then it will become 2 cube minus 1. So 2 cube is 8, and 8 4s are 32, that is 31. So it will become, here we can write it as, this is the values. So this, after calculating this, we can write it as 2 minus f2 is 4 by 31. And if you will do the calculation, you will get the value as 2 minus 4 divided by 31, which is equal to, we can get value as equal to 1.8 7. Here 9 is there, so we can write it here 1. So this is our first approximation. So x1 is this. So this is the value of x1. So this one is x1. Here we can write it as x1, and this x1 is equal to this value. Okay, so this is the value of x1, and now similarly we will put in place of n, we will put 1, then we will get second approximate value, then again afterwards we will put 2, then we will get third approximate value. Whenever our value will become equal, then we will stop our process there only. Okay students, so our x1 is 1.871 and our fx is as given this, and f dash x is this. So we can use this all for finding out. Now we will put let n is equal to 1. So it will become x2 equal to f1 minus of fx1 divided by f dash x1. So x2 equal to x1 is 1.871 minus of fx1. If we have to put, then fx1, it will become, here we can write it as 1 to the power 4 minus 1 minus 10 divided by 4. This is f dash 4, 1 cube. Okay, wrong, it is wrong, as we have done some mistake. Here x1 is value of x1 is this, so we will substitute 1.871. So x2 equal to become x1 minus fx1 divided by f dash x1, and you know the value of x1, so we can substitute the value of x1. It will become 1.871, and here we have to write 1.871 divided by f dash 1.871. So if we will substitute all the values, 1.871 minus 1.871 to the power 4 minus 1.871 minus 10 divided by 4, 1.871 to the power 3 minus 1. So if we will substitute this value, and if we will calculate with the help of calculator, we will get 1.871 minus it will be 1.871 to the power 4, then minus 1.871 minus 10, and in denominator it is 4 multiplied by 1.871 to the power 3 minus 1. So after calculation, yeah, we will get 1.856. So this is our second approximate value. This is our x2 is this. Now again we will find the value of x3. So we will put n equal to 2, and if we will put n equal to 2, the third approximate, here we have got second approximate value. Now the third approximate value is x3 equal to x2 minus fx2 by f dash x2. So this is the value. So if we will substitute here, so it will become 1.856 minus 1.856 to the power 4 minus 1.856 minus 10, this whole divided by 4, 1.8, yeah, you will get 1.8556. You means approximately we can write it as 1.856. So hence x2 and x2 is also a 1.856 and x3 is also 1.856. So we can hence the desired root is 1.856. Okay student, this is our next question. Find by Newton's method the real root of the equation 3x equal to cos x plus 1 correct to 4 decimal places. So here our fx is 3x minus cos x minus 1 This is our fx. If we will put 0 here, then it will become cos 0 is 1, and minus 1 it will become minus 2, that is negative. And if we will put 1, then it will be 3 minus, you can put here 3 multiplied by 1 minus cos 1 and then minus 1, so you will get 1.45. So 1.45, if you means at whole calculation you will get 1.45, which is positive. So this shows that so our root lies between 0 and 1. Okay, so as 1.45 and minus 2, if we will see number line, then my root is so much near to 1 only. So we will take see, as you can draw a number line, and here I am drawing 0, and first earlier we are getting 1.45, and here we are getting minus 2. At 0 we are getting minus 2, and at 1 we are getting 1.45. So we are so much near to this, and our root will be must between means it should be between 0 and 1. Okay, here I mean 0 and 1 is this. So to get this we can choose any number. So now I am choosing here x naught as 0.6. You can choose any of the number. How much perfect nearer number you will choose, you will get an answer more quickly. So I am taking here x naught. Now if we have to find f dash x also, as fx is given as 3x minus cos x plus minus 1. So if we will do differentiation, then x cos x differentiation is minus sin x, so it will become plus sin x. So this is the value. Now we will use now by Newton-Raphson formula, we can calculate it, because we know that the general formula is this: f xn divided by f dash xn. This is the general formula. So at n equal to 0, we will get first approximate value. So it will become x1 equal to x0 minus fx0 by f dash x0. So how it will be, x0 is 0.6 minus fx0 means this value we have to put 0.6 minus cos 0.6 minus 1 divided by at f dash x3 plus sine 0.6. If we will calculate this, see, first I am calculating this part. 3 multiplied by 0.6 minus cos 0.6 bracket close minus 1, and down it is 3 plus sine 0.6. Then we will get as it is 7 point, means very less number. We can do one more thing here. It's very less. It is something about 0.6 minus 0.0 because 10 to the power minus 3 is there, so 0.07. Okay, 0.07 something, it should be the value 107. So if you will subtract it, means answer, if subtracted by, or we will add 0.6, then it will become 0.59, 0.5928 something we are getting. So we can do one more thing. If we will calculate this. Okay, I am doing it at a single calculation only. 0.6 minus divided by 3 multiplied by 0.6 minus cos 0.6 minus 1, then add down it is 3 plus sine 0.6. then our answer is 0. It's our answer is 0.60710. Yeah, this one. Now with the help of this we have got 0.60710. Now similarly, if we will find out the second by putting n equal to 2, we can find the second value. Okay, if we will put n is equal to 1, then we will get the second approximate value. Second approximate value we will get. So according to formula, it will be x2 equal to x1 minus fx1 divided by f dash x1, and my x1 value which we have got earlier is this, so we can put it here as 0.71 minus x1, then 3 multiplied by 0.071 minus cos 0.6071 minus 1, 3 plus sine 0.6071. So if we will do the calculation of all these, so we will get it as 0.6071 minus 3 multiplied by 0.6071 minus cos 0.6071 minus 1, then it will be 3 plus sine 0.6071, so it will be equal to 0.6071. again you can see that it is again 0.6071. so it is very in two steps only we have got the result, as at x1 is 0.6071 and x2 is 0.6071. so hence x1 is equal to x2, so hence the desired root is 0.6071. so one question I am giving you students, this is practice question, please solve it using Newton iterative method, or you can Newton-Raphson, it can also be written as iterative, or you can write it Raphson. So Raphson method, find the real root of x log 10x equal to 1.2. okay, this is the question. Correct up to 5 decimal. okay, 5 decimal or 4 decimal you can do it. so this is the question for practice, please solve it, and if you have any doubt while solving you can ask, and you are not using discussion forum, use it, and please watch the videos also, because as I have estimated that you are not watching the videos, so please watch it, because it's all about your semester syllabus, and if you want to complete your semester syllabus properly, so you have to see the videos also. Thank you.